In this demonstration, I would like to show you the differences between soldering with a traditional 60-40 solder, which is a lead base, 60% tin, 40% lead, and the lead-free solder, which is going to be 99.3% tin and 0.7% copper. For this demonstration, I will solder two 8-pin ICs on a circuit board. What I'll do is I'll solder one side with the traditional 60-40 solder and the other side with the lead-free, so you can have an easy comparison between the two. I will start off with the 60-40 solder. I have my soldering iron set to a temperature of 650 degrees Fahrenheit. So this is the tin lead solder. You can see that I have nice shiny joints. Goes fairly quick. And we've got 8 pins soldered. Now I will do the remaining 8 pins using the lead-free solder. The only difference is now I'm going to set my soldering iron temperature to 750 degrees Fahrenheit. Ideally, I would have to replace my tip, and a tip that would be only used for lead-free soldering, if I'm going to comply to the restrictions of hazardous substances, ROHS. We also have a sponge that I use to clean my soldering iron tip that is dedicated to lead-free. This will prevent cross-contamination of the lead-free joint. Now, for most practical purposes, the home hobbyist building kits, the student or engineer that is doing a small project, you can easily get away with using the same soldering iron tip and the same cleaning sponge without any problems. Okay, so let's go at these next 8 pins with the leaded solder, or lead-free solder I should say. Now I'm going to leave my iron on the joint a little bit longer, and then I'll bring my solder in. It takes a little bit longer to complete a solder joint using lead-free. I'm making sure that everything is heated up well. There we go. You can see straight off that the solder joint does not look near as shiny or reflective. There, now I got a bit of a rhythm going. There we go. So now I've completed those 8 joints with the lead-free solder. Now let's clean the solder joints off with the isopropyl alcohol and my toothbrush. You can use liberal amounts of the rubbing alcohol, as it'll help remove the flux from the circuit board. Now for this example, I used a small chisel tip for both the leaded solder and the lead-free to ensure that I got good heat transfer onto the pad and the component lead. So now let's take a closer look at the two solder joints. At the top, I have the lead-free, and at the bottom, I have the leaded solder. The leaded solder requires a much lower temperature for soldering. You can work at anywhere from 600 to 700 degrees Fahrenheit, where the lead-free You need to move your temperature up 100 degrees. So you're going to be soldering somewhere between 700 and 800 degrees Fahrenheit. You definitely don't want to go over 800 degrees Fahrenheit because you may cause problems with the printed circuit board. You'll delaminate pads. You may cause warpage on the board and component damage. The 6040 solder melts somewhere between 361 degrees Fahrenheit and 374 degrees Fahrenheit, as opposed to the lead-free, which melts at 440 degrees Fahrenheit. For the solder that I was using today, the 99.7% tin and 0.3% copper solder, lead-free solder. Due to the higher temperatures for using lead-free, you can expect your soldering iron tip to not last as long as opposed to using leaded solder. Again, the big difference between the two is that the leaded solder is a lot more reflective as opposed to the lead-free, which is not very reflective. To summarize, the lead-free solder will require soldering temperatures that are much higher, anywhere from 700 to 800 degrees Fahrenheit. I used in this example a temperature setting of 750 degrees. Due to the higher temperatures, you can expect your soldering iron tips to degrade much quicker as opposed to the leaded solders. Once you get used to using the higher temperature and the little more laid-back process of soldering with lead-free, you will adapt very quickly to it.